Guys, I am just going to run you through some Excel basics using the zero dilution class data and show you how to make all of the different graphs, add error bars, all of that stuff, just to get you guys started. So first, I want to bring your attention over to the pipetting and graphing Canvas page. Here, if you scroll all the way down, you'll see a little breakdown, basically just an at a glance how to graph with Excel. This could be really helpful if you guys just need a little pointer, you forgot like what to do next. This would be good to kind of also, in your own words, if there's like any gaps that you want to add to your cheat sheet or add to your ELN if you're having a little trouble on how to do the graphing. Here also is a link on how to download the desktop app for Excel. If you just scroll all the way down and scroll here, either if you have Mac or Windows, and then it'll take you over to how to download all of like the Office apps, and it's completely for free through UF. Definitely go ahead, take advantage of it, because I really deter people from using the online version UF offers. You will run through a lot of problems if you try and use that. So definitely download the desktop app if you can. Also, whenever we have shared class data like this, don't ever try and do your calculations on the shared file or delete anything from here. Because it'll mess up everyone else. So really all we want you to do whenever we have shared class data is just copy paste it and then onto your own Excel file. So this is pretty basic, but for those that don't know, shortcuts on how to copy paste, you do Control C to copy, Control V to paste on Windows, and then Command C, Command V on Mac. So yep, now we go to our Excel file and then just Control V on there. Here, as you can see, you have the overflow for these. That means it was just too concentrated for the spectrophotometer to read. So we're just going to disregard these two lines here. And then we want to kind of make this a little easier for us to graph in the future. So what I'm going to do is I am just going to move this around. Yet again, this is just, I think about it as setting myself up for success in terms of the graphing, because like you'll see in a bit, it just makes it so much easier and it saves you some steps in the long run. So here, I don't want to keep the A, B, C, D, etc. Because that's meaningless to me. I want to know what each of these rows mean, right? So I want to know what like dilution factor they were at. If you see, whenever you try and do, let's say like the 1 to 100, it'll give you a weird number. There's two ways around that. The reason why Excel is doing that is because it's trying to calculate it for you. But obviously I don't want that right now. So things I can do are either I can add a little apostrophe, like a single quotation mark on there, and then that makes it so I'm telling Excel, hey, don't calculate for me. I want my what I'm typing like to show up verbatim. So for example, whenever you do like an equal sign, let's say like 5 plus 10, it'll calculate it for you. But let's say I want it to show 5 plus 10. I can do the little singular quotation mark and then equals 5 plus 10, and then it'll actually show it. So that's a little trick with Excel. Or if I don't want to do a singular quotation mark for all of them, I can just highlight whatever cells I want to apply that to before I put any numbers down. And then here, under the home page, go down and then select text. And then, as you can see, I can just freely start typing and then it won't calculate it for me. So just writing the different dilution factors for all of them. And now we can actually start graphing. So the first graph we want you guys to make is a line graph with all the class data. So I am just highlighting everything that I want, including my labels for my different axes, because it'll save me time and then I won't have to do it after I plug it in. So here you go to insert, you go to these little graph symbols, and then under the line graph symbol, you just press the first one. And here we go. You're like, that does not look what I expected it to look like. What went wrong? If we take a look at it, it's doing each individual seat number and then all of the data from that. We don't want that. We want to have these dilution factors in here instead. So what we're going to do is under chart design, do switch row and column, and there you go. That makes a lot more sense. However, right now, this is an incomplete graph because I have no clue what it means or what it's trying to say. So how I change that is first I go to the little plus sign and then add axis titles. Then you want to make, for every graph you make, you want to have a descriptive title. Let's see. So a good title for this could be like serial dilution class data. And then, like I said, you want to label your axes always. Just practicality, you want people to know what they're looking at. And yet again, you will be taking points off if you don't label it properly. So dilution factors for X. And then this here, what it's measuring is the OD readings, the optical density. And I want to specify that that is at 600 nanometers. Because, for example, if we weren't using crystal violet, we wouldn't be using it at 600 nanometers. It would be depending on what we're using. So it's important to specify. Okay, awesome. So here is our finished first graph. Now, the next graph we usually ask you guys to make is one with the average class data compared to your own individual data. So first, to do that, you need to find the average class data. And then whenever you're taking averages, you always want to include error bars to show that spread. So to do that, you want to also find the standard deviation. So let's go ahead and just find those first to then save us a bit of time after. So here I am just going to copy, actually let me make sure that yet again I'm doing these as text. That way I can freely copy this without worrying about Excel making some weird stuff. So here I can do like average class data. And then, so yeah, here, actually, I'll just make this the mean. I'll make this the standard deviation. And the reason why I'm adding a space is because for later, thinking about myself in the future, I'm going to copy paste my data here. So for the mean, how you find means is you're not going to individually be plugging this into a calculator with this much data. It's just unrealistic to do so. So we're going to utilize Excel's function feature to do the work for us. So the way you do that is you just put an equal sign, then that is kind of telling Excel, calculate whatever I want for me. And then you can do this one of two ways. So for mean, the function for that is average. So you can just type that out yourself and then just select the numbers that you want to average. So for example here, just going to highlight that and then click enter. So then that averaged it for me. Or I can do equals and then select the little FX insert function button. And then, for example, if I forget all of the different functions, I can just go ahead and do that here. Click OK, and then that'll start calculating. And then same as before, you just highlight what you want it to average and then click enter. If you don't click enter and then you instead click on a different cell, Excel will get confused and it'll be wonky. So just every time you're dealing with functions, just click enter. That way it doesn't mess things up. So now with the 1/1000, yet again, you can just keep repeating all the steps, but to save myself some time, a quick little tip is if you highlight something and then you drag at the corner, Excel is pretty smart and it'll pick up on the pattern. But you always want to check because sometimes Excel doesn't pick up on the pattern and you have to like help it a little. So I always just double tap to check and then I'm like, oh, perfect. That is exactly what I wanted it to highlight. So then I'm good. So now for the standard deviation, same idea as before, equal sign. Yet again, I just like to go to FX. And then you can either do the stdev, but I know in some like Excel versions, stdev doesn't really work all that well. So you can also do, just put stdev.p. That one's also fine. Just try it on your version. If stdev doesn't work, it gives you like an error like message, or it's just not there, you can just do the other one. But yeah, stdev, like I said, it works for me. So what you want to do is that I like personally just going onto here, double click it, and then same thing, just highlight what you want it to calculate the standard deviation for. And then usually for Excel, I like to give it at least 2 different like examples before I do the drag and drop, just so it knows pretty well. If you just do one, it won't really know what you're trying to make it do. And then drag, and always, like I said, double check to make sure it's doing the right thing. Perfect. So I'm just going to use a random student's data as an example. And now, like I said, the purpose of me trying to do this is I'm trying to make a graph comparing like one student's data to the class average. So here, and then actually I'm just going to now label this class data average, because now when I go ahead and select this and yet again go to insert here, 2D line, it's already labeled for me, so I don't have to worry about messing with labeling after the fact. Perfect. So then yet again, you always want a descriptive title. So I can do class data, or let's see, serial dilution class data average versus my data. Is it a little long? Yes, but what matters is that I know what I'm doing. So, or like what I'm looking at. So here I'm going to add, always add access titles. Yet again, same as before. These would be the dilution factors. And then these right here, OD readings at 600 nanometers. Awesome. What is missing now? The error bars. And here's the thing: a lot of students get confused and they accidentally add error bars. Let me just move this out of the way. Okay, that is not wanting to cooperate. You know what? It's fine there. We don't need to move it. So yeah, so a lot of students get confused, and a common mistake we see is they add error bars to both lines. Why would that be wrong? My, like, quote unquote, my data here is not an average. For these, it's just all of my data points. So there's nothing to do the error bars for. The error bars, it's like you have an average and you're showing the spread of those. But here, there would be nothing to show. So I only want to do anything of average, add error bars to that. So I want to click the line that I want to add error bars to. This one is the class data. And then you can go to chart design, add chart element, and then error bars. More error bar options, scroll all the way down here, click custom, specify value, and then this is why we calculated the standard deviation is for this here. For the negative error value, you're not actually adding a negative, you're literally just selecting the same data. Okay, there we go. and that is our error bars complete. So that is our second. Let's see if maybe I have more. Okay, awesome. I can actually move it this time. That is our second graph complete. There's a third graph we want you guys to make. That is the bar graph of your data compared to the class data. But this time you're actually doing the averages of the trials, because if you were publishing your results, you're never going to include duplicates. We just wanted to do the duplicates so you guys could see. For example, this student, their first one and their first and second duplicate, like there should have been like this. They should have been pretty similar to each other because they're the same value. So it kind of should have been like a little stepping ladder, but you can see that this one was a lot lower than the first. So that way it's just a good indicator for you guys to know how you did well per well. But like I said, if you were publishing our results, we don't want to put it like that. We want to just have the duplicates be averaged out. So yet again, we can just do that. So 1 to 100, 1 to 1000, and then control. And then this is class data, my data, then standard deviations. And now all of these would be average. So we're going to do a formula for all of these. So we're finding the mean, yet again, average. But this time around, the difference is we're going to average both sets because we're doing the average of the duplicates. So here we go, equals average, and going ahead and doing that. Yet again, I always like to give Excel 2 things so that it knows, and then I can just do it for the third. Here's a good example as to why I always check. If you click it, you can see it didn't pick up on the pattern. And if I had just not checked, I would have gotten wrong results. A good way to fix it, it still saves you time, is you just literally drag it and make it where you want it to be. So honestly, we can just do that from the first one. Average. Oh, I hate when it does that. That is why I just like doing this. Average, and then we're doing the individual data. So here I use student 1 for this one. So here, if you just drag and drop, like I said, did this one pick up on the pattern? No, it did not. So yet again, I just drag it to what I actually want the pattern to be. So click it. This one also did not pick up on the right pattern, so I'll just help it out. But yet again, it still does save time because you're not actually having to like write out the formula. There we go. And then same thing for standard deviation. We're just using the stdev formula instead. Oh, that did not go where I wanted to. Oh, I don't know why my cursor is not stdev. There we go, that's better. Then just adjusting. You never just want to like blindly trust Excel. Excel is very smart, but it doesn't always understand what you're trying to do. Okay, awesome. So now to do a bar graph, very similar to making a line graph. You just highlight the data you want to include. Here, sorry, it's doing the weird thing again. Why is it doing that? I guess sometimes Excel is very finicky. Let me just try and write something random to fix it. Okay, it's not. Whatever. Let me just try and still select. Hopefully this will work. Okay, awesome. There we go. Select the data you want. Yet again, you're not selecting standard deviation for this because that is just for the error bars. Oh, actually here, I only calculated the standard deviation for my data. I also need to calculate the standard deviation for and this labeling is just so I know what it's for. So equals ICDev. Like I said, this is pretty tedious. But it is definitely something, like I said, if you're ever publishing data in a paper, something you have to do. There we go. And like I said, the little drag and drop does save time. You just have to make sure you adjust it. And then by that, you just double click and then drag and drop. Cool. Okay, now we have everything that we do need. So let me just highlight the data I want to graph, insert right here, go to little bar graphs, and then this is the one that we want. Perfect. Yet again, what is missing? Axis titles and a proper chart title. So we can just do class data versus my data, and then just do serial dilution, class data versus my data. Here, same as before, nothing new. Dilution factors. And here, OD readings, 600 nanometers. Like I said, very repetitive, so you become good at it pretty quickly. Awesome. So now what is missing is the error bars. These two have different standard deviations, so they're both going to have different error bars. Let's click on the blue, that's class data. Same thing, add chart elements, then go to error bars, more error bar options, go over to this little guy under error amount, custom, specify value. Same thing, this is the class data, so I want to go to the standard deviation for the class data, highlight that, erase this, same thing, highlight those same values. Okay, and then you'll see it's properly adjusted. Now I just want to repeat the same thing for the my data one. Go down to error bars, more error bar options. Here, custom, specify value, and then this is the one for the my data. Oh, here, let me just, there we go. My data. My data. Okay, awesome. Then you can see that they're different. And how to interpret these. That is obviously a very important part of the graphs and how to interpret, especially error bars. So for here, what you can see is you can actually see for the individual like wells is if you are within the error bars, you're not considered an outlier. If you're outside the error bars, you're considered an outlier. So here, technically at this point, if you look close enough, it's not within the error bars, so that would be considered an outlier. This one is perfectly within the error bars, so that's great. Within. This one is cutting it close, but it's still within the error bars, so you wouldn't consider an outlier. If we look here, same thing. If they like overlap, then you're good. These do. The longer error bars just means there was a wider range, which makes sense with the class data. You have what, like almost 60 data points total per dilution factor, versus for your data you only have 2, so they should be smaller. But yeah, that are the 3 graphs that you guys need to include for your like serial dilution lab, and these are just really basic like graphing tools that you will definitely need in the future and for future labs. So if any of you are confused, please reach out to any of your TAs they will talk you through this process, but hopefully this little video tutorial was helpful for you.